So like everything else in the past 3 years, I think Lab2FAB looks different this time around, wouldn't you say? This time we're starting with a series of online virtual seminars where you can hear from some of the speakers in the workshop program before you get to meet them face to face at the workshop this September. So this September, look forward to joining us in Whistler, BC, September 25th to 27th. But despite all the changes, the mission of the Lab2FAB workshop has not changed. It remains a platform for industry and academics and government to collaborate in overcoming their R&D challenges. These are challenges about prototyping and manufacturing and designing microsystems innovations. Three of the main thrusts that define the Lab2FAB workshop are building capacity for competitiveness, nurturing partnerships for high value outcomes. And I think one of my favorite aspects of this workshop is how being in the same place, being in the same room, helps us to align our priorities, no matter which kind of organization you're working on, and what your angle on the ecosystem is. We've been doing this now for 7 years. Lab2FAB started as a biannual meeting in 2015. Here, first hosted in the Center for Research in Photonics at University of Ottawa. And since then, it's been hosted at venues right across Canada, where participants meet to collaborate, to network, to form connections that I think pay off in work in collaborative dividends in the future. And of course, then today, with this series of seminars, we are ramping up to 2022 Lab2FAB coming up in Whistler, BC. Hope to see you all there. I want to open by thanking our sponsors who make this possible. Our gold sponsor, Lucida Photonics, silver sponsor, Aponics, and then a number of lab sponsors at universities. At Simon Fraser University, 4D Labs. At the University of Sherbrooke, the 3IT. The Toronto Nano Fabrication Center at the University of Toronto, and the Center for Research in Photonics at the University of Ottawa. Thank you for being part of this, and thank you for helping to make this unique event possible. Along the bottom of your screens here, you see the co-hosts. This year at UBC, the Stuart Buson Quantum Matter Institute, and SciEpic Fab, all at the University of British Columbia, partnering with CMC Microsystems to bring you this workshop. Today we have a great lineup, 3 speakers, each presenting a different, unique angle on the question of how you move innovations from the lab to the fab. I'll introduce each one of these speakers briefly, and just to give you an idea of the format of our webinar today, during the speaker presentation, I'll ask that everyone but the presenter, please keep your video and microphone muted. I will we'll keep an eye on the chat for questions that might come from the floor. And then at the end of Gordon's presentation and Mosen's presentation, I'll have time to field maybe just 1 or 2 clarifying questions about their presentation. Following the the first two presentations. We'll have a plenary discussion where all of you will have the opportunity to chip in, to ask or to answer questions along the lines of the workshop's topics. And then we'll close by seeing a short feature presentation from the Toronto Nanofabrication Center and the facility that is available to use there. So without any further ado, I'd like to introduce Gord Harling, who is the president and CEO of CMC Microsystems. Gord will speak to us today about CMC's plan for advanced technology manufacturing in Canada. So welcome, Gord. I see your video is on. You have somewhere around you. So you've got 15 minutes, including a question. So maybe leave some time for that at the end. I'll hand it over to you now. Thank you very much for joining us.
I'm going to talk a bit about a proposal that we have in front of the Canadian government, which we call Fabric. And it's it's an ecosystem that we want to build for doing semiconductors in Canada. It is not a big CMOS fab at the state of the art, but it does secure our domestic supply chain in some specific areas. This is an old slide. It's actually in 4 areas of domestic manufacturing that we want to extend Canada's leadership. And focus on existing strengths, fabs that already exist in Canada that we want to expand and facilitate. As an overarching theme to this fabrication effort, we want to talk about IoT, using components built in Canada to build IoT devices for advanced manufacturing, healthcare, agriculture, and so on. We have 14 founding partners, CMC plus 13 others, who touch on each of the areas that we're addressing. And we're asking for $120 million from the government over a 5-year period. And most of this money will be used to pay foundries to develop processes, which CMC will then offer brokered access to, so aggregation. And we're also looking for some co-investment from provincial governments. And we're working our way through that right now. So what are the 4 manufacturing streams? Silicon photonics is doable in Canada. Currently, this year, CMC brokered 137 designs from folks not only in Canada, but around the world, using applied nano tools, using advanced microfoundry in Singapore, and using global foundries, factories in the US. That's a real upswing because typically we do about 80, but we spent about $1.2 million to buy all of this fabrication access from other countries, and this could just as well be made in Canada. The beauty of silicon photonics is it doesn't race down to 5 and 3 nanometer. Photons stay around the same size, so the gratings, the waveguides, of course, will remain the same, and equipment can last for years as opposed to 18 months before it's obsolete. Another area is micro-electromechanical systems. So we have the world's largest open foundry in Canada at Teledyne and Bromont, but we don't want to deal with smaller customers. So how do we develop a burgeoning ecosystem of MEMS companies? A lot of them work through university labs. Some of them have some basic setups of their own, but we need to create a MEMS process that's intriguing, interesting, and useful, but that will handle small volumes as people need to grow to the point where they can become a Teledyne customer. So what we've been doing is with our own staff and with external consultants, we've been developing 5 different MEMS processes. They're relatively quick turn. We can get a chip out in 6 to 8 weeks sort of thing. But they're all quite unique, these 5 processes, and they can be bonded together afterwards to create more complex 3D systems. So we're very excited about that. I call this specialty semiconductor. In fact, it's compound semiconductor. And so the NRC fab in Ottawa can build gallium nitride devices and indium phosphide devices. So, but they typically engage with large customers who develop a custom process just for them. So they don't have the liberty to offer us space in those runs. So what we're going to do is pay them to develop a specific GaN process for us for very high speed circuits, and work on the indium phosphide side and photonic circuits, and create processes that we can then market and broker worldwide. And finally, in quantum devices, Quebec is very committed to building superconducting devices in Canada. And so they have, through a variety of programs, they've invested in the equipment and an expansion to the C2MI in Bromont to build aluminum-based superconducting devices. So CMC ran our first superconducting design course last summer. We're having the devices fabricated in the US, but eventually we would like to bring them back to Quebec and have them fabricated here. So that is a very unique skill and a very unique area where we could punch well above our weight. And finally, how do we commercialize these? Well, as we build sensors in these different technologies, we'll embed them into IoT devices. And so the intent here is to assist people in developing IoT products for commercialization for sale. And so we are already starting slowly within our means to develop each of these manufacturing processes to try and make the processes that exist more complex and sophisticated and of more interest. But the fabric funding of 120 million over 5 years would obviously give us a huge boost and allow us to generate revenues from the sales of these processes, so that they, by the end of the 5-year term, they would actually be self-supporting. We've been TELUS is a lead partner in Fabric, and they have a 5G marketplace for listing commercialized devices. So we want to develop some IoT reference designs with them. And we address the entire innovation chain from manufacturing to commercialization. So it's a way that Canada can pick some niches and move ahead in semiconductor without having to necessarily attract a $10 billion CMOS fab. We would love that. CMC would be very happy to support that, but we don't think that it's in the best interest of Canada. So there are 13 founding partners across Canada, 8 industry and 4 university. This is very complementary to Canada's National Design Network, which is the MSI that CMC operates. And we have currently over 300 user groups who are going to benefit from this program. And as time goes on, of course, we'll engage with more and more people. We are also signatories to the Minister of ISED's 50-30 challenge for equity, diversity, and inclusivity. These are the partners. They range all across Canada. Sorry about the Atlantic provinces. We'll try and do something with you later. And these are the economic benefits we expect over the 5 years to support $1 billion in R&D expenditure by our partners, to train 4,000 new grads, so about 800 a year, and provide education for K-12, try and stimulate more people to go into STEM and understand these technologies. We'll create new knowledge-based jobs as folks leave school and go to industry. It'll generate intellectual property to the extent that not only will we have design IP, but there'll be process IP, and it's very hard to deconstruct a process technology and understand how it was built if you have a different equipment set, different materials. So these processes, once they're developed, will be unique to Canada, and we'll be able to maintain our advance there. It'll also create a domestic supply chain of a few types of semiconductor chips, and it's really a pan-Canadian ecosystem. And that's it.
Next up, I'd like to introduce Edward Xu, who is at the Toronto Nanofabrication Center at the University of Toronto. He's going to just tell us about the facility they have there. Hello, Edward.
Hello, hi, Andrew. Hi, good afternoon, everybody.
Yeah, I can see and hear you loud and clear. So thanks very much. Handing it over to you. You've got about 5 minutes, and then I'll come back in for our discussion time. Go ahead, Edward.
Okay. Yeah, good. Okay. Thanks a lot for the invitation. So just give 5 minutes presentation for talking about the TNFC. So TNFC is a typical open access micro-nanotechnology research facility in University of Toronto. The purpose for this facility is to serve innovation platform for the users coming to prototype their micro-nano devices. So since the COVID-19 hit and shutdown of the operations, and we actually got the good timing as well to undergo a massive consolidation project. Basically, before we had actually three clean room facilities across the campus. So by taking advantage of this shutdown time, we actually consolidated two major clean rooms together into one place. So this project is almost done, and by the end of this month, we're going to reopen the facility. And in terms of the organization, we have, so right now, after consolidation, we only have two clean rooms right now. So here, the Micro-FAB clean room facility, we now have about the class 1,160 square meter area for the lithography and all these processes. And for the dry processes, we have a class 10K 240 square meter area. And also we have testing area as well for packaging as also. So, and for the e-beam nanolithography, because it requires a solid ground, so we put this facility in the basement of a building in Warburg. And we also have a couple of partnership with various organizations to enhance our capability.
Edward, sorry to interrupt, Edward. Your slides aren't advancing on my screen. If you are clicking through them, they're not advancing.
Oh, really? Oh,
Yeah.
so okay. How should I do that? Sorry.
It's still on the first slide for me. Maybe at the bottom of your, underneath the slides, it still shows 1 of 11.
Yeah.
Yeah, if you can click forward there, please.
Is it moving now? Sorry, is it moving? Is it changing?
No, I'm still looking at 1 of 11. But maybe I think viewers can click forward through themselves. So maybe just narrate through. Okay. Oh, sorry. Yeah, they are moving for others. So sorry about that.
That's funny. I didn't know that. I was thinking. So how should I
keep going? Keep going. I think it is moving for other viewers. Maybe it's just me. Okay.
Okay.
So sorry for the interruption.
Sorry. Yeah. And if you look at this right now, number 3 slides, so you can see that our facility is right in the downtown area, and in front of the campus, College Street. There's yeah, on the 4th floor. There's a corner of this building. We are doing the reconstruction of the bigger clean room. And so if I go to the next slide, yeah, so that's the overview of the our facility. If you see, so the key research area is basically for MEMS, microfluidics, and microsensors, etc. All kinds of micro devices, I can say. And the process capability that we have, we are keep improving the capability as well. But based on the current facilities we allow the users can prototype MEMS for sure, and microfluidics, and some micro power devices like gallium nitride, HAMT devices, and also the photovoltaic devices, as well as gallium nitride LED devices. All these processes can be done in the facility. So, and this is our website, and we use the thanks for the Albert LAB2FAB provides us LMAX management system. We got this system to manage the open access of all the pieces of equipment, which proved to be really efficient. And yeah, the booking and the logging system. That's LMAX. All right, and before the shutdown, so before the renovation of the clean room, by the end of the year 2019, we have this operation results. So in terms of the operation, we had at that time we had some funding from Dean's Strategic Fund, EC Department support us for the space and the utilities, and the other major portion should be earned by us by provide users to access all various equipment. So in the year 2019, we improved to get a total usage of more than 23,000 hours in a whole year, and total revenue from the user fee just exceeding $500,000. So that makes us a good balance in terms of the operation, but we still have lots of challenges because since 2020, the Dean, the Strategic Fund is stopped. We don't know why, but anyways, so afterwards, so we have to try our best to apply more funding to sustain ourselves. And yeah, so if you look at this, this is the renovation progress. So in here, you can see the layout. This yellow area is for lithography, and here is for dry processes, plasma, etchings, PCVD, and evaporation, deposition, RTP, etc. And surrounding this area is the supporting area, and here in green shaded area is for testing and the packaging. And yeah, so I think I'm over the time, so just acknowledge thanks for all the support from CFI and RC, University Department and CMC as well.